everyone, I'm Tamara from Toloka. I'm currently working on solutions that help to improve our clients' search systems and recommender systems. My talk will be mostly focused on the systems that are used by e-com magazines, shops, but this information can be scaled to any area where you use recommendations. I will start with brief introduction on you all have heard some of your friends telling that your phone is listening to you because it's like showing you on the search something that you have just thought about or just told your friend. And I've got lots of my older relatives, and I'm sure somebody is spying for them. But the thing is, and you all know about this, that some websites have such powerful recommendation systems that it seems like somebody is reading your mind, but it's just like several neural networks, and you're so predictable. But there are companies that come to us. They have problem with something isn't working, and they are not in this category of companies that I'm telling you about. So we have collected the list of problems that they face because of bad recommendation systems. And it's lots of relevant stuff on search engine page and in recommendation section. And you're it's somebody is looking for a Galaxy Note, and instead of getting some nail polish because it's number 10, it's long time to find search elements, high churn rate of users. These are problems that relate to most of e-coms, but not every company knows that they can be solved via offline labeling. And I'll tell you how. What is offline labeling? You use the power of crowd to make a decision to determine whether search results or maybe recommendations are useful to the user who will see them. So for example, in this page, you see this is some search on the internet, and you ask our performers to classify which of the products in the output are relevant or irrelevant, or which category. And after classification, you know everything about your output system, because online signals, it's something implicit. So you know that user have clicked on some web page, on some item, and looked through it, but you never know what was his intention. Maybe he saw a beautiful picture, maybe he made it by random, maybe he just wanted to check something. And it's an implicit signal. You never know whether this is caused by something that interests you. And also, you all know that it's not more common for e-coms, but for some such systems, it's a big problem that if you use only click-through rate, your model can get really prone to clickbait. So there are search systems, they never use only click-through rate, because otherwise you will get in your results page some articles on Madonna's looking hot, or maybe how to cure cancer with soda. It's real cases. So this is the problem that you can face if you use only online signals. But offline labeling is just a useful tool to correct the things that is going a little bit wrong in your system. Offline labeling helps you to first achieve scalability, because every company has faced the problem of cool start when you have a new user or maybe new product and you don't know what weights to assign to it or how to promote it. And if you ask directly with offline labeling, you will already have like this information. And also it's a good way to enrich your ML model, because now we all know that ML and DL models are like some giants feeding the much data you feed to it, the better it will get. So current models have already seen the ordinary types of data that they have been fed up to, but adding like offline data can help you just get out of this like glass floor and go to next level of quality. It's like a small example of how can your offline labeling project look like, the simplest one. So you have iPhone 13 and you show to performer on like some labeling platform two uh, two items. It's this smartphone and the case, and you ask the user, is it a correct recommendation or incorrect recommendation? And because such verdicts are really cheap and fast, you can collect a vast amount of data, and you will be sure that the items that your recommendation system is showing are really valid. Another type of this product could be like, instead of this case, you got another case and you ask which one is better. It's like about what Yair was talking, like pairwise comparison and pairwise ranking. Sorry. So, and it helps to increase the accuracy and recall of like ranking, of recommendation. And I wanted to tell you about how to use offline labeling in recommendation systems based on what are the main fields in recommendation systems right now. So you all must know about them, but let me just briefly introduce them. So the first one is collaborative filtering systems. It's the one when you look through your users of the website, you check what they were looking through, what they were choosing, what they searched, what they have bought, and after this you like make this matrix factorization and find the similar users that have similar interests and can buy similar items. Another type of filtering systems is demographic. You like try to extract recommendations for different type of demographic stratas, like different ages, different genders, education background, and etc. The third one is content-based. It's information filtering methods when you look not at the customers who have already bought this item, but on the items itself. So you try to produce as much product features so that you can compare the items in your catalog and find which are mostly close to each other. And the fourth one is knowledge-based filtering methods. And this is like the job that all companies are doing all the time. It's like about doing research on your customer needs, on what is trending right now, what people want, what people will want. And it's also shouldn't be like underestimated, because it's a simple tool, but it helps you just to get into the apple of the people's needs. And the fifth category is hybrid filtering. So you can actually take any of these and combine them. This will have like a more difficult neural network structure, because for some of them you use autoencoders, for some of them you use matrix factorization, for some of them like difficult ranking system, but like playing with factorization and autoencoders helps you to get these data into one batch of vast amount of data that you can use to predict some recommendations. And this is what gives you this effect of somebody is listening to us. It's like a little bit noisy because you have data of different types, of different categories, but if you settle the weights perfectly, it will look very good. So now I'll tell you how offline labeling helps to get this data. First of them is content-based filtering systems. So for them, you can just, you've got lots of items in your catalog, but you just kind of, there are some features you can extract, but some features that are hard to extract from the catalog by ordinary NLP models, and sometimes you need like these hand-picked answers to first train these models, and second to like get more vast information. For example, there is a big problem in e-commerce that is called asyn to asyn, because like some companies have different catalogs for different for different regions, and they have a problem to match the items from catalogs of different regions. So it sounds like it's your own catalog, it's items that you sell inside your company, but some information is really hard to retrieve. And to do this, you maybe can use some models, but to use models, you need to first train them. And here is where labeling helps you. And also you can just like ask any other questions about like items that you are showing to your customers. So the next one is knowledge-based filtering systems. It's about like trends or some needs of customers. One of our great examples is that we like made a project on fun toys for recommendations. So there are recommendations on the web pages that are connected to some items, and recommendations on the main page that are just some stuff that you would recommend your users to buy. And like you can just ask users whether the product that you show to them is an unusual product or an ordinary product, or maybe is this skirt trendy or not, or maybe like it's already cold, would you prefer this blouse or this blouse? So lots of different questions that you can ask your performers. And for collaborative filtering systems, crowdsourcing is kind of not enough developed, but I see that there is some room for improvement, because you actually can like show to labelers some search queries of different users and ask him whether these users belong to some cluster or not, or maybe what the users that were searching this thing. So for example, somebody was looking for beer, for diapers, for like, I don't know, some books for children, whether he's like, you can ask the performer whether he is a single father or maybe like somebody else. It's like you actually can impose any question you have. So the problem here is only to make the data anonymous. And for demographic filtering systems, we have lots of, and other crowdsourcing platforms have lots of filters that you can imply, so you will get the precise customer auditory that you will use to sell the items. So you just take the same slice of audience and ask them whether they're interested in these items or not. And I would also like to show you some other ideas of how your projects on crowdsourcing look like for relevance. So for example, somebody is looking for music system and we show him some items and ask him whether they are relevant or not, or maybe for coffee bean grinder, this item, is it substitute, complement, relevant, or other? Or maybe if try to define for which category some such query could belong. For example, what was person intending to get when he was looking for some kitchen table. After this, when you train your model to extract such data, you can also build your recommendation on them. So, for example, if you know that your user is looking for some hairspray for oily hair, you know that the keyword here is oily, and everything that you will show him later will recommend him something with this keyword. Again, this is complementary goods. It's either pairized, showing that either this item is better for this one, or maybe ranking of how relevant this item is or not. And for category recommendation, you know that user is looking for some dress. It's a really non-trivial problem, and you make a recommendation inside this category, and you recommend the needed categories to the user. And another example here is there is a problem in such systems whether when somebody is looking for Jaguar, is he looking for a car or for an animal? So you need to first evaluate the category, then to rank the categories, and define which one is more suitable now. But there are some blending models now that help you to enrich the search output with both categories. But you can also label data to make this model. And fun goods to recommend is something I was showing you before. Crowdsourcing helps you to get answers for all these questions. And actually what I wanted to show you is that you can use crowdsourcing for any possible question that you have. So you know you have trouble with something, you use crowdsourcing, you build some simple model or download something from GitHub, relabel data with crowdsourcing, and using transfer learning, adapt this model to your problem, and you implement it to backend, and you have a simple solution to what was torturing you and decreasing your sales. But another thing that crowdsourcing can be used for is evaluation process. So you have created some model, you are showing something to people, and you actually need to get sure that you are showing something that is valid. And so this problem, it also shows how crowdsourcing works. You just take output of your ML model, you sample the required amount of data that you want to examine, you send them to crowdsourcing, you ask people whether the recommender system showed that for this region, for this gender, and for this age, these clothing categories could be useful. So you ask users whether they think that the model was right or not. You aggregate answers, and you get the verdict, you calculate metrics that is like evaluating your model, and after this you can make a verdict whether your model is working good or not, whether you can like have some spaces where you can boost its work, and you can do it anytime you want. And I also wanted to show you this slide. It's Yair mentioned something like this at the end of his presentation. So about introducing some models to your backend. It's another use of crowdsourcing here. Uh, decided to show this slide because we like talked about it earlier. So if you have several recommendation models, you need to decide which of them is predicting better. So conducting online experiments can be really expensive, especially in like e-commerce when you really lose money when you show something irrelevant. That's why you can first create an offline evaluation and check for output of each model, how good it is working, and like score your models, choose the best of them, and after this send them to online. And then you can like out of 10, for example, different models with different hyperparameters, you can choose very fast and very cheaply. You can choose, for example, 2 candidates that go later to online evaluation. And after this, of course, there is A/B testing and all this difficult stuff. And again, I would like to conclude that crowdsourcing is like a tool that you can use for any problem on this planet. And these are like slight list of problems that we tackle daily, but actually when clients come to us, they often have some really different problems and really weird ones, but we know that with crowdsourcing we can solve most of them. And it's like not the thing that will replace AI or vice versa. It's like the thing on which shoulders AI and ML is built and can be improved and improved later. So that's all. Thank you.